Hey guys, here we're going to talk about Pythagorean's theorem, which is a theorem that helps you to solve for sides of a right-angled triangle. So here we have our right-angled triangle, and a right-angled triangle is a triangle that has one angle that is equal to 90 degrees, okay? So usually you would see it represented, or the angle that has the 90 degree represented by a little box here. And the sides of my right angle triangle, I'm going to label A, B, and C, where B and A are the legs of my triangle, and C is the hypotenuse. Now, the hypotenuse is also the longest side of my right angle triangle, and it always is going to be opposite the 90-degree angle in your triangle. The Pythagorean theorem states that the sum of the squares of the two legs, so the sum, that's plus, of the squares of the two legs, so a squared and b squared, the sum of the squares of the two legs, is equal to the square of the hypotenuse. So that's going to be c squared, because our hypotenuse is represented by the letter c. And so this is the Pythagorean theorem. And we are going to apply that to a problem or two. In this example, we're given a right angle triangle, and we can label our legs and our hypotenuse right away. The legs of a right angle triangle are the parts that make up the actual 90-degree angle, or that form the 90-degree angle. The 90-degree angle is here. And so this side and this side form our 90-degree angle, so they are the legs. We can label them A and B. And the side that is opposite the 90-degree angle is always going to be your hypotenuse, and that is going to be your C. Okay, so your C is X. With that being said, let's go ahead and write out the theorem. A squared plus B squared is equal to C squared. In other words, the sum of the squares of the two legs is equal to the square of the third side, or the hypotenuse. We can now substitute into our equation. A is 6, and when that has to be squared, plus B, which is 8, and we have to square that as well, is equal to C squared, and our C is represented by the letter X. So we have X squared. Now, remember your order of operations here, because it does apply as well. PEMDAS. Some versions have BODMAS or GEMDAS. Whichever way you remember it, just remember to apply it whenever you do a mathematical problem. So the first thing we know, we don't have any parentheses or any grouping symbols or any brackets. And the next thing then we would look for is exponents. Well, we do have a couple of exponents here, so let's see how we can simplify that. 6 squared is 36, plus 8 squared, which is 64, is equal to x squared. Well, x is something that we don't know. It is our unknown, and so we can't do anything with that at the moment until we solve for x. The next thing I'm going to do is simplify a little bit further. If you look at the left-hand side of the equal sign, 36 and 64 are like terms, so you can go ahead and combine them. 36 plus 64 is 100, and that is equal to x squared. Now, take a minute to look at what you have. The side that we're looking for is represented by a single x, and it does not have a square term or a square power. In this expression that we have here, our x is to the power of 2, and so we need to get rid of that. How would you do that? Well, in previous videos or in previous examples, you would know that multiplication and division are opposites. Addition and subtraction are opposites. And when it comes to the square, something squared, the square root of that is an opposite as well. In other words, they undo one another. You can look at our video on order of operations or on opposite operations to see how that works. But let's keep going. In order to get rid of your square, I have to square root both sides of my equation. And I'm going to go ahead and rewrite it. 100 is equal to x squared. And I must square root both sides. And the reason I'm doing it on both sides is because what you do on one side, you have to do on the other. The square root of 100 is 10, and that is equal to x. The square root of x squared is simply x. And so our unknown side is x. Let's look at another example. In this example, we have a right angle triangle, and we're going to go straight into applying this theorem. A squared plus b squared is equal to c squared. The first thing I would encourage you to do is always label your sides first. Label the legs and label your hypotenuse. A, B, and C. Next, you simply substitute straight into the formula that's given. A is 16 squared plus B is x, and that has to be squared, and that is equal to C squared, which is 24 squared. Now, we can go ahead and apply our order of operations, and 16 squared is our first thing we're going to tackle. That is 256. Plus x squared, which we don't know at this moment, so we can put it back, is equal to 24 squared, which is 576. Remember, our goal is to solve for the missing side, which is represented by x. So we need to isolate the x squared first before we can find the x. In order to do that, let's get rid of the 256 that's on the same side as the x squared. 256. We're subtracting because we have to apply opposite operations. What we do on one side, we have to do on the other. (256 minus 256 is 0. And we're left with x squared on the left-hand side, and that is equal to 576 minus 256 is 320. Now, once again, as we did before, we don't want x squared. We want x by itself. And so the opposite of the square is the square root. And whatever we do on one side of the equation, we must do on the opposite side. The square root of x squared is simply x, and that is equal to the square root of 320, which is going to be approximately 17.9 inches.